Good morning, good afternoon, or good evening, depending on where you are in the world. We'd like to present to you lesson 8 of, of what I've learned from basic electronics. And if you haven't seen the first 7 lessons, I recommend that you do that before, because each lesson will be building upon previous concepts. So they will be reused, they'll be used as it is cumulative in a building. And now let's get to the actual lesson itself. Now, what we're talking about today is called batteries. And most people have heard of this idea of batteries, as it is not a new idea, something we use every day. But let's talk more about theory of it, how it works, etc. Now, with batteries, one of the major things we want to do with batteries is estimate the battery life. Okay, so there's different aspects when we talk about how long a battery will last or its battery life. Now, this has to do with the capacity of batteries specified in ampere hours. Now, amp has to do with the current flow, denoted by capital I, and in the formula, or in physics, is denoted by capital I. So, ampere hours, this is how long uh, power can be generated through a current through in terms of a period of hours, denoted as lowercase m, capital A, lowercase h, being milli. Instead of capital M would be mega, but this is milli. A capital A uh, amp is ampere, and lowercase h denotes hours. Thus, milliampere hours. Now, let's say we want to calculate how many hours your battery will last. You need to divide the number by the current consumption of your project. In terms of A, this would be milliamperage. Okay, so for one example of it would be 200 milliamperage hours divided by 20 milliamperage hours. Therefore, we'd have 10 amperage hours of power of usage, otherwise known as 10 hours of usage. Now, ahead of us, we have a series where we have 4 batteries using 6 volts each in a series, meaning all 4 are being used. The current flow is 9 milliamperage hours, and our resistance through the circuit is 470 resistance, and the output is an LED light. Now, here are some important things to consider. It is best to avoid putting batteries in parallel because none of the cells in the battery will be exactly at the same voltage when you connect them together. The first thing will happen in their voltages will equalize with higher voltage batteries, discharging them into a lower voltage battery. Okay, so basically what you have to do is you have to have the same type of batteries with the exact same type of voltage if it's gonna be in a series. Okay, so they have to have exactly the same voltage. Okay, very important. Now, so basically if the batteries are rechargeable, you may be okay if the voltage difference is small enough, or in this case very small, but non-rechargeable batteries, this charging process can heat the batteries and can be dangerous because we have a difference in the voltage. The other thing is that perfect batteries allow you to draw a large current as you want, large as the current as you want. However, in reality, batteries have a small resistance that will cause heating as the battery discharges. Why? Because the lower the resistance, the more current you're allowing through a circuit. Also consider that the higher the current, the greater the heat produced, as I was just saying. Remember that resistance in a circuit will limit the current flow. Smaller capacity batteries have a lower maximum discharge rate than larger batteries. Why? Has more stored power inside of the battery itself. Now the chip will automatically control the charge current, turning it to a safe trickle charge when the cell is fully charged. However, you can set a maximum charge current in amps or ampere. You'd want to consult whatever data sheet you're using for lithium Po cell that you plan to use. Means of R1, which is resistance 1, using the formula that is the current flow maximum equals 1000 over the radius. Why? Because I equals V over R. Okay, very standard formula in electronics, but very important to know. Now, LiPo batteries, as lithium Po batteries, have made news in recent years because they will catch fire if abused. Just like a lot of things electronics, you have to be careful not to abuse it. Using a charger chip like the MCP73831 in your circuits will help ensure your design is safe and reliable. If you remember from last lesson, it was a controller on the chip that controlled the voltage going in compared to the voltage going out. Okay, so if you remember that from last time. Now what you can do, as we talked about last time, we can use a thermal fuse. This is to prevent an excess of current flow. So for extra safety, you can use a thermal fuse to the supply to the charging circuit. Why? We want to prevent damage to the circuit by taking on, once we've exceeded the current past a certain amount, it will blow. And remember, we talked about two different types of fuses last time. So anyway, that is the main idea. Now, if you're looking for a lower tech solution, consider using nickel MH or SLA batteries. Instead, unlike nickel MH or SLA batteries, LiPo batteries are not suited for charging in parallel. This is one at a time. So you're charging one battery at a time. Each cell effectively has to be charged independently using special hardware. If your project cannot operate directly from 3.7 volts of a lithium Po cell and needs a bit more voltage, then it's generally easier to use a boost converter. And actually, I don't have to put that there. Sorry, that was from a previous project. Now, the novelty circuit known as Joule Thief allows you to power an LED. So the output of the power on a resultant, it basically would be an LED from the alkaline AA cell, even when its voltage drops to around 0.6 volts. A Joule Thief is actually a small self-oscillating boost converter. Remember, we talked about inverters and converters. Transformers and inverters. Now this converter, so remember we talked about AC to AC and AC to DC and DC to AC. Okay, so we have a boost converter. Now a boost converter that requires just transistor, resistor, okay, resistor, transistor, okay, so that will manage the current flow and the voltage, and then a resistor will regulate and impede the amount of current that goes through a circuit. Now, homemade transformers, and also you have homemade transformer to drive LED from a single 1.5 volt battery, even when the battery voltage drops below 0.6. Why? What does a transformer do? Transformer reduces the voltage. Okay, that's the point. Okay, so transformer is going to be important in this case because we are stepping down the voltage, we're not stepping up. Okay, so remember that a circuit is very similar to the operation of a self-oscillating boost converter. Use an excepted one of a secondary winding. So we used the converter earlier, but in this case has the same number of turns in the primary and connected back to the base via resistor rather than parasitic from the winding. So when we look at the circuit coming in, here's this example of a Joule Thief schematic. What we're looking at is we're looking at the actual voltage to ground. Coming into the circuit, we have a resistance, denoted as R1, through 1K of voltage. I'm sorry, the 1K, yeah, 1K of load, and the circuits on one end is 12 and 12. Um, on each side we have polarity, a positive polarity that will be the electrons coming in, and it goes through a controller part of a chip, which is 2N3904, that controls the voltage in and out. And the resulting part of the battery powers the LED. Okay, so that's what it is. So this was kind of shorter compared to the other lessons, but it gives you a good idea. I mean, there's lots of variations. There's lots of ways we can do this. Notice I did show that we have a maximum current flow, and remember that current equals voltage over resistance. So we had a maximum current is what we were trying to calculate, and then what we did was we took the voltage coming in divided by the resistance passing through the circuit and give us our current flow maximum. All right. Also, we talked about batteries in series. Remember, batteries in series, you have to be careful how we do that. And we also have materials, so we have to compare nickel MH to LPO. Remember, LPO can only have one rechargeable one at a time, versus nickel you can recharge multiple ones at the same time, which is normally what you would see with your rechargeable batteries. Sorry, right here, I went past it. Also, just as a reminder, as a review, we talk about amperage hours, milliamperage hours. So what we're going to do is we take the milliamperage hours divided by your milliamperage. So it's time over actual resistance will give you how many hours is available for, as in the maximum milliamperage. So you have the milliampere hours here versus the milliamperage will give you the hours. So in this case, you take the numerator divided by the denominator and you get your quotient here of 10 amperage hours. Okay, so all right, and then one more point to remember is that when you first come into a circuit, we have a voltage. Now remember that each one has to have the same voltage, otherwise we can burn out our circuits. We have to, each one of these batteries in parallel have to have the same voltages. So total voltages is 6.5, each one being 1.5 each. Then we have our milliamperages, which is that would be the total power going through. So what you do is you take your 6, you multiply by 1.5 for each one. So you take the total and you do the opposite of that equation. So instead of dividing, you're multiplying. So what you're doing is you're taking the actual voltage and you're multiplying. You're multiplying by each one in parallel. So 6.15, we get 9. That's milliamperage hours. It gets past through resistance, and then that will power our device at the end, which is the LED. Alright, so that will end it for the lesson. This was shorter, but this one was important to know, as each electronic component is important to understand how it works and how it works in a circuit accordingly. So I'd like to first of all take this time to thank you for watching these videos. You could be watching any other tech or science video, so I certainly appreciate that. But as this did provide value to you, that is to be educated or get a refresher on basic electronics, what I'd like you to do is please click like on the video. That way I'll be pushing the algorithm, more people will be able to view it and enjoy it. If you haven't already, please click the subscribe button. That way you'll have access to all the content on this channel, as I do have a variety of content on this channel for you to enjoy and benefit from. Also, if you haven't already, please click the bell button. That way you'll be notified of all my future videos. That way you won't missing any new videos as they come out, as you will be notified accordingly, especially with YouTube. But I will have this posted both on YouTube and Rumble. So, I want to wish you a great day wherever you are in the world. Take care, and I'll talk to you next time.